In part 2 of section 17, we're going to look at something called the inverse function. Now, the inverse function requires us to have an understanding of the one-to-one type function, which is what we looked at in part 1, where we looked at definition 17.1 and then also that horizontal line test. Now, for this next example, I really want to just look at some special observations that we can make about this pair of functions that I have for you. So let's look a little more closely at this pair of functions. F is given to us as a cube root function, the cube root of x plus 3 minus 2 with the domain of all real numbers. And then G is given to us as a cubic function, says x plus 2 cubed minus 3, also with the domain of all real numbers. And the first part of this, I want you to list the operations of each function in order. So for F, I want you to think about what would be the appropriate steps that I would have to take in order to be able to find the y value given a particular x. That's what the equation does. The equation gives us the steps to be able to do that. Now, if I was in a middle school class or a junior high class, I might list these things out just as a means for them to see how the equation really does give us a particular order, because in that setting I would be introducing our orders of operations probably for the first time with them. So I want to do the same thing with us here. So let's say I wanted to evaluate f of 5, for example. Of course, you have to substitute in the 5, but once you substitute it in, where do you start? You should start with adding 3. So whatever you plug in for x, you have to start with the addition of 3. Let's write down for step 1, add 3. Okay, so then that means we would have the cube root of 8 minus 2. Next thing you would have to do is then perform the cube root of 8. So let me write down cube root for step number 2. And the cube root of 8 is 2. Now we have the statement 2 minus 2, which means I then would have to subtract 2 from that value. And I'll write that down as the third step. Subtract 2. So for every x value I work with, this would be the same 3 steps I have to go through to find the y value to go with it. I want to do the exact same thing for G. Now with G, I'm not going to write it all out step by step like I did here with the equation. I'm just going to list it all out in English. So let's go ahead and start on that. G is going to have 3 steps. So looking over at the equation for G, we have x plus 2, which means I'm going to have to start with adding 2. My second step will have to be to cube that result. So I'm going to write cube here for step 2. And then for step 3, I have a subtraction of 3. And we'll write down subtract 3. Now it makes perfect sense that these two lists are not identical, because the equations are not identical. They have a different set of steps, different set of operations that are required to execute their calculation of the y value. But they're not so different that we can't make some kind of connection, some kind of pattern recognition here. And this is what inverse functions are all about, is finding a particular pattern. If you look at step 1 on F, and you try to compare it to step 3 on G, these are what we call inverse operations. Adding and subtracting are inverse operations, and here we're adding 3 on F and then subtracting 3 on G. Those are a very interesting pair of operations. And we can do the same thing with step 3 of F and step 1 of G. Subtract 2 and add 2. Those are also inverse operations. And even step 2 to step 2, cube root and cubing, those are inverse operations of each other. So it's interesting here that comparing f to g, we have inverse operations, and it's also in the reverse order. So this is definitely not just two random functions. There's a rhyme or reason to why we're looking at this particular f and g, and it's because of this very cool connection between their orders of operation. Now I want to take this a step further in part B, where we're going to look at the graph of each one of these on the Cartesian coordinate plane. So each one of these is an opportunity to practice your transformation. So I would encourage you to pause the video and practice working on your transformations graphing if you need. I'm going to go ahead and work on f. This is a cube root function, then shifted to the left 3 and down 2. So I want to set up the points for that. I'll label that as f. G is supposed to be a cubic function, shifted to the left 2, but down 3. And I'll draw that one step at a time. And that gives me the graph of G. Now, they are two different shapes, but they are different in such a way that they create a pattern. I want you to look specifically at the identity function for a moment, which is given by the equation y equals x. Y equals x is a very special linear function, and if I use this linear function as a dashed line, if I draw it as a dashed line on my graph, then it's going to serve a very important role when looking at these two graphs. The line y equals x ends up serving as a line of reflection for these two functions. If I was to fold a piece of paper on this line, let's say that we had the graph on a piece of paper, and you fold on that line, the graph of f and the graph of g would become indistinguishable. You wouldn't be able to tell the difference between the two. They would land right on top of each other. So this is a very interesting observation about these two functions. We've seen that they have operations that are inverse operations of each other, but in the reverse order. And now we see from the graphical perspective that they have this line of reflection with the line y equals x, and there is one place where these two functions intersect with each other, and they intersect right there on top of that line of reflection. Also an interesting observation. Not a coincidence either. So let's take a look at the third activity, and that is to find f of g of x and g of f of x. These are compositions. If we need to go back and look at section 5 where we talked about compositions, now would be a good time to do so. So for f of g of x, we're going to be looking at f of x plus 2 to the third minus 3. So you have to be very careful about keeping up with your parentheses. Where are you substituting it in? So take your time with this. On f, there is a single x represented underneath that cube root. So that's where I'm going to substitute in the expression for g of x. So this is going to say the cube root of, and I'm supposed to substitute in x plus 2 cubed minus 3. And then that has 3 added to it, finishes off the cube root, and then minus 2. So as I'm looking at this statement, which has now gotten pretty involved, I have to think about the list of the operations again. What would be the correct order that I would want to cancel this stuff out? Or try to evaluate this, I should say. I would start with plus 2. Then I would have the cube part. That would be step number 2. Then the next thing would be subtract 3. and that finishes that big parenthesis there. Then I would have to go to the plus 3 next. That'd be step 4. Cube root would be step 5, and then the minus 2 would be step 6. So there are some inverse operations here, such as the plus 2 and the minus 2, but they are not next to each other in the order. The plus 2 is the very first step, the minus 2 is the very last step. So it's not possible to be able to cancel those operations out within the structure of this algebra. However, step 3 and step 4, which are back to back, are inverse operations, minus 3 and then plus 3. So I do have the ability to be able to immediately cancel the minus 3 and the plus 3, which is going to give us the cube root of x plus 2 cubed, and then I'll have that minus 2 there at the end. So if I do that same exercise, think about what's the order of the operations, then the first step would still be the x plus 2, second step is still the cubing, but now the third step becomes the cube root, and the fourth step becomes the minus 2, in which case the cube root and the cube are inverse operations of each other, and they're right next to each other in our order. They can cancel, which is going to leave us with x plus 2 minus 2. And then not much to really think about here because plus 2 minus 2 should just cancel out, leaving us with x. So very interesting cancellation that occurs when we're looking at the composition of these two functions. Let's do the opposite composition. That'll be g composed with f of x, and see if the same thing occurs. This will be g of the cube root of x plus 3 minus 2. So for g, I have a single x here next to that plus 2. So let's open up a parenthesis, and then we'll open up another parenthesis to plug in the f of x expression, plus 2 all cubed minus 3. So if you go through that same process that we did with f of g of x, of thinking about what's the order of your operations, you will find that one pair of operations will cancel, and that is the minus 2 and the plus 2. So that's going to give us the cube root of x plus 3 all raised to the third minus 3. And again, there is a single pair of operations that will cancel here. That is the cube root and the cube, which leaves us with x plus 3 minus 3, and we can get the plus 3 and minus 3 to cancel, finally leaving us with x. So again, very interesting observations here at many different levels. At the equation composition level, at the graphing level, and then just at the basic order of operations level. And it's not a coincidence that these two functions have these interesting properties to them. More on that to come in the discussion on the inverse function.